Well, the junior class is planning the prom for this school year. The venue is going to cost $1,200 to rent, and there is an additional cost of $25 per person for food. So let's suppose 100 people go to the prom. How much total money would it cost? And then how much would it cost per person? Two questions within this one question. So we're going to have the total amount, and that's going to be one answer. And then we're also going to have the amount per person, and that's a different question altogether. So the total amount, let's switch colors just for fun. The total amount is going to be, well, let's see, it's going to cost us $1,200 to rent this place. And then we're going to charge $25 for everybody that comes to get food. It's not that we charge it at the door, but it's going to be built into the ticket price. So 25 times 100, and there we go. So we're going to have $1,200 plus $25 for every person. That's $2,500. And so $3,700 to put on the prom. I made these numbers up. It's not necessarily realistic. I don't know. Amount per person. Okay, well, here's the deal. So if it costs $3,700 and we're going to split it among 100 people, then, I think we're going to do 3,700 divided by 100. Yep, you with me? Hope so. All right, so let me write it out in a way that'll make sense as we move forward. So the amount per person is going to be, well, 1,200 plus 25 times 100, and you're probably like, 3,700. I know, I get it. I'm picking up what you're putting down. But if we write it like this, then when we get to the next problem, you'll see the structure of it. And this would be 37. 37. There we go. That's an awkward looking 3. $37. Okay, write a function to model the cost per person at the prom if X people attended. So this C of X is going to be the cost per person. Cost per person. Okay. Cost. Well, it's going to cost $1,200 no matter what you do. And then you're going to have to charge $25 per person just to cover the food. But then you're going to split that cost evenly among the X people that went. It's this, only in the place of 100 where you put an X. That's it. Now, you could have also done it this way. I'm going to write it on the paper. I'm going to use a scrap piece of paper. I'm going to stick with this one, but this is also a valid representation. $1,200 needs to be split among all the people that come, and then I'm going to charge $25 per person. So this is really like 25x divided by x, and the x's would cancel if I'm just looking at that right there. So these are equivalent. This is the one I'm going to be dealing with a little bit more. So as we go to the next question, it says, where is the vertical asymptote of this function? Well, it's where your denominator equals 0. And we could look here and still say the same thing. But it's where your denominator equals 0, and then what does it represent? Well, let's draw a quick graph of this. And we're going to have a vertical asymptote at 0, and I'm looking ahead here. Horizontal asymptote, linear, they have the same degree. Divide the coefficients, 25 divided by 1. So this is going to be y equals 25. Now, I know I'm a little bit ahead of myself, but I need a horizontal line at y equals 25. That's my horizontal asymptote. And I need a vertical line there, and this of course is the y-axis, but it's where x equals 0. And so the actual graph itself in purple is going to look like this. Now I'm lying to you, the graph doesn't look like this at all. Because, and here's why. I just drew a continuous graph. This data is discrete. Whoa, what's that mean? Okay, can you have 1.5 people at the prom? No. Okay, you can't have half a person. And then don't try to get technical about all that stuff. You can't, all right? So you can't have decimals. You can't have irrational numbers. You can't have negative numbers, which I did not include. It would be on the graph of this actual function itself if we were not talking about the number of people that attended. But technically, if I really want to get technical, this would be a series of dots. Because I could have 1 person at the prom, 2 people at the prom, 3 people at the prom, 4 people at the prom, 5 people, you know, you get the drift. So drawing it the way we're used to seeing it as a continuous function, we have a horizontal asymptote, that's the next question, vertical asymptote, that's the current question, and that x equals 0 means that, follow along here, as the number of people that attend the prom decreases, the y value goes up. What is the y value? It's the cost per person. So as the number of people attending the prom decreases, the cost per person increases drastically. Now, again, if this was a continuous function, like if we could truly plug in 1/2 here, or 0.1, or 0.01, or 0.001, we would approach infinity. You won't have someone paying infinity dollars for this prom. But you could type it in your calculator and just kind of get a feel for it. And I've done this already. I've typed it in. One person shows up at the prom, you're going to have a cost of $1,225 per person. 2 people is $625. 3 people is $425. So the more you have, the lower it goes. How low does it go? Well, it's never going to cross this horizontal asymptote, and that is y equals 25. So as the number of people attending the prom increases, the cost per person. Okay, you might be tempted to write the word decreases, and you'd be right, but let's get really specific. It approaches $25. All right, and it makes sense. It really makes sense, because you got to have $25 to cover the cost of food, right, per person. But then you're going to take this $1,200 and split it evenly among everyone that comes. So the more people come, the more you're splitting this evenly. 100 people show up at the prom. Well, each of them's going to have to pay $25 at least, and then 100 people show up, and so it's going to be 12 extra bucks. 25 plus 12, there's your 37. Okay, so here's what I had in the calculator previously. I already typed this one in. So and it's going away. Come back. If I had 100 people at the prom, $37 a person. We've established that. 1,000 people at the prom, $26.20. 10,000 people at the prom, don't do that. You need crowd control for that one. $25.12 per person. Now, of course, the prom committee would need to make money, and then there's decorations, and so it's not a fully realistic scenario, but it's a general overview of the type of thing that this function is handy for.